Good afternoon, ladies and gentlemen, and welcome to my presentation on SENIS magnetic sensors. In order to measure complex motor movements, both 3D linear sensing and angular position sensing are required. For example, in this robot application, the new SENIS 3D Hall sensor is applied to control magnetic gripper feet, and the SENIS fast magnetic angle sensor is applied in the knees of the robot to precisely measure angles for accurate control of fast actuators. In my presentation today, I will present these two new SENIS magnetic sensors based on the Hall effect. And because a magnetic sensor always comes in combination with a magnet, it is also important to know the characteristic of the magnet in order to optimize the entire magnet sensor system. So these magnets have to be measured, and this is done with the SENIS 3D magnetic field mappers, which I will also introduce today. But let me first give you an introduction on what SENIS does. We measure magnetic fields and electric currents. We provide magnetic sensors and instruments based on the Hall effect. For example, for automotive, consumer markets, and other industrial applications, for test and measurement, mapping of magnetic fields, position and speed sensing, and current sensing. We provide products with a combination of unique performances: the highest accuracy, stability, and repeatability. With our solutions, we move the limits of the feasible in magnetometry and sensor technology. The traditional Hall effect sensor, also called horizontal Hall sensor, measures only the perpendicular component of the magnetic field. A three-dimensional magnetic field sensor can be composed of three such classical Hall effect sensors in a cube, but the disadvantage of such a sensor is the large sensitive volume and the high non-orthogonality of the sensitivity axis. Many years ago, the founder of SENIS, Professor Popovic, invented the first vertical Hall sensor that enabled to measure the in-plane component of the magnetic field. The combination of vertical and horizontal Hall sensors enabled to develop the first integrated three-axis sensor. That was 20 years ago, and today SENIS again could invent and patent a new generation of 3D Hall sensors, the world's most compact 3D Hall sensor with highest magnetic resolution available on the market. Here are the facts. The sensor has the field sensitive volume of only 100 times 100 times 10 micrometer cube. That's the spot in which all three components of the magnetic field, Bx, By, and Bz, are measured. Due to its high spatial resolution, the sensor is well applicable for the measurement of highly inhomogeneous fields. The magnetic resolution is 1 microtesla. This high magnetic resolution is due to the performance of our patented vertical Hall elements. They feature at least 3 times better signal-to-noise ratio than any other vertical Hall sensors available on the market. Moreover, we apply special spinning current technique for an efficient offset and noise cancelling. The measurement ranges of this 3D Hall sensor are selectable. The sensor has high frequency bandwidth from DC to 300 kHz. It is easy to integrate due to the standard analog and digital interfaces. So this whole 3D Hall sensor is, for example, applied in the robot application for the control of magnetic gripper feet. But it is also applicable in magnetometry, joystick, proximity sensors, 3D switch, current sensing, and with our 3D Hall technology, we can also make various arrays of compact, real 3D Hall sensors. Why should you apply the SENIS 3D Hall sensor? Because it provides accurate, stable, and repeatable measurements. It has patented technology. It is highly parameterizable, easy to integrate with competitive price. Based on our unique technology, we have developed also other Hall magnetic sensors and instruments for various applications in industry. For magnetometry, translation, and rotary displacement and current sensing. Some of our well-known solutions are, for example, the SENIS 3D magnetic field mappers for quality control of permanent and electromagnet, or our 3D Tesla meter with the highest accuracy and resolution that is also used as a reference Tesla meter at various metrology institutes. And we provide also smart sensors for integration in robots or other industrial applications. In our product solutions, we always combine some unique performances such as the highest resolution, accuracy, and high frequency bandwidth. For example, the resolution of our 3D Tesla meters is 1 microtesla, and its accuracy is 0.01%, while the frequency bandwidth goes from DC to 5 kHz. This is unique, particularly in combination with the high spatial resolution of our 3D Hall sensors. And this is the reason why our customers say about SENIS that we are moving the limits of the feasible in magnetometry and sensor technology. The other sensor I will present is a fast magnetic angle sensor, FAMAS. It allows contactless measurement of the rotation angle from 0 to 360 degrees with an angle resolution of 0.08 degrees and a delay of only 0.6 microseconds. The rotational speed is from 0 to 400 kilo RPM, and this sensor has been awarded several times for its performance and innovation. It is applied for smooth motor control in robot applications, for example, in this robot called ANYmal. It is a quadrupedal robot that operates in challenging environments where humans cannot or should not go. This magnetic angle sensor is applied in the knees of the robot. It precisely measures angles with very high resolution for accurate control of fast actuators. Why was the FAMAS sensor selected for this innovative robot application? Because of its combination of unique performances. It gives quickly the direct angle information due to a patented algorithm. There is no need for sine, cosine calculations, no AD converters, and that makes the sensor faster and less expensive. It has very high angular resolution due to the high fidelity patented vertical Hall sensors that we apply here. Unique is the sensor stability and high resolution at 0 and at very high rotational speed. The sensor is applicable for motor control, for high-speed machinery, and also in surgery robotics due to precise and fast small angle measurements. This sensor is easy to integrate and highly parameterizable. For example, if you know well the magnetization error of the magnets you are using with your sensors, you can optimize the performance of the entire sensor magnet systems. But how can you know precisely the deviation of the magnetization of the magnets you are using? You must measure the magnet. Here is an example of a magnet sensor system. In this picture, it is applied in the ANYmal robots. And here is shown the magnetization of the magnet, the ideal theoretical case and the real case in practice that shows that the magnets have some magnetic angle deviations. We should know the magnet performance in order to optimize our magnet sensor system. And so we measure this magnet with the SENIS 3D magnetic field mapper. The mapper applies a compact 3-axis Hall probe. The mapper accurately positions the probe and measures the 3D magnetic field around permanent magnets and electromagnets. As an example, here the measurement of disc and ring magnets diametrically magnetized, which are usually used with angle and position sensors. So our 3D mapper maps around the magnet and it visualizes the 3D graphs of the magnetization and provides some analysis. For example, the angle error of magnetization, the inhomogeneity. It visualizes the magnetic flux density Bx, By, and Bz, and these values were measured in one single spot. You may recall that I explained earlier in my presentation that our 3D Hall probes are composed of both horizontal and vertical Hall sensors, and everything is miniaturized so that you measure in one single spot of 100 times 100 times 10 micrometer cube all three components of the magnetic field. And that's why we talk here about real and reliable 3D magnetic field measurements. Let me show a short video on the SENIS 3D magnetic field mapper to give you an impression on how we measure the angle deviation of the magnet. The 3D Hall probe is mounted on the mechanical moving platform. The mapper probes are easily interchangeable due to a smart touch sensor. So in order to measure the angle deviation, the magnet is positioned on the rotary stage in such a way that the geometrical center is well aligned with the rotation axis. Magnet is rotated for 360 degrees, and during the rotation all three components of the magnetic fields are measured. The real magnetic angle is calculated as arc tangent Bx, By. At the same time, the encoder mounted under the rotary stage is measuring the angle of the rotation of the mapper, giving the ideal angle. The difference between the real and the ideal angle gives the angle deviation. The entire scan process takes only a couple of seconds. The SENIS 3D mapper also measures rotors, encoders, and entire motors. Several companies worldwide apply the SENIS magnetic field mappers, Tesla meters, and magnetic sensors. For example, Magnet Physics, Maxon Motor, Melexis, Porsche, and many others. We know how to calibrate 3-axis Hall sensors. SENIS Calibration Laboratory is the only ISO 17025 accredited laboratory that calibrates 3-axis Hall probes and magnetometers in all three directions, also for higher magnetic fields. We also have a patented solution for calibration which enables to determine very precisely the orthogonality of the 3D Hall sensors. This is our infrastructure. The SENIS team is spread over 3 locations worldwide. At our headquarters in Switzerland, we focus on R&D, IP management, strategic marketing and sales. Detailed engineering, production, test and calibration is done in our facilities in Serbia. And in this new building, we have our laboratories. Here is shown the clean room, calibration test lab. And our third location is in China for the business development of emerging electronics markets in Asia. This is our core team with highly educated and experienced people. It is our mission to move the limits of the feasible in magnetometry and sensor technology in order to provide better solutions to our customers. Our presence is global. Wherever you need us. Thank you for your attention.